So today we are going to talk about a fascinating topic, that is a mode of action of enzymes. So before going to that, what are actually enzymes? Enzymes are nothing but biocatalysts. Similar to motor from helping in drawing water from the well, the enzymes increases the rate of reaction of biological reactions. So the enzymes are biocatalysts. The catalysts are nothing but substances which increases the rate of chemical reaction, but they do not change the equilibrium. You will understand the statement when we see the other slides. Almost all enzymes are chemically proteins. So a different mechanism of action is proposed for the enzyme. One such thing is the lowering of the activation energy. If this is a graph with the time in the x-axis and energy in the y-axis. According to this theory, the substrate, that is the yellow one, is at a lower energy level. It has to be first raised to a higher energy level, transition state, before getting converted to the products. So for converting substrate to transition state, an energy is required. That is the activation energy. So the green curve represents without enzyme and white is with enzyme. So you can clearly see that the activation energy required is less with enzymes. So what does enzyme actually do is it reduces the magnitude of activation energy. But one important thing to note is delta G, that is the difference between the free energy of the substrate and the free energy of the product, that remains same with and without enzyme. So it is like jumping over a fence. What does enzyme do is it reduces the height of the fence so that substrate can easily be converted to products. So it is the mechanism of action is lowering of activation energy. Activation energy is defined as the energy required to convert all molecules of reacting substance from the ground state to the transition state. Substrates are at a lower energy level and their energy has to be raised for spontaneous degradation. That energy is called the activation energy. The enzyme reduces the magnitude of this activation energy. So that is one mechanism of actions. Next one is the Fisher's template theory. According to this theory, the enzyme and the substrate is like a lock and key. Only a particular key can open a lock. That is, only a particular substrate can bind to the active site of the enzyme. Even structural analogs cannot bind to the enzyme. But this theory fails to explain the flexibility shown by the enzyme. Next one is the Koshland's induced with theory. So first one was lowering of activation energy. Second one is the Fisher's template theory. The third one is the Koshland's induced with theory. According to this theory, when the substrate binds to the enzyme, it leads to conformational change in the enzyme. So that leads to a proper orientation between the substrate and the enzyme. Hence, it increases the rate of the reaction. So the substrate get converted to the products. So when enzyme combines with the substrate, it leads to conformational change in the enzyme, which leads to proper orientation, which helps in the reaction and which leads to formation of product. The third one is the Michaelis Menton theory. According to this theory, the enzyme combines with the substrate to form the enzyme substrate complex, which splits into the product and regenerates the free enzyme. The backward rate constant of this reaction is very small, hence we ignore that. K1, K negative 1 and K2 are nothing but rate constant. We can see this in detail in the next video. So in this video we saw about four mechanism of action. First one is the lowering of the activation energy. Second one was the Fisher's template theory. Third one was the Koshland's theory, and final one is the Michaelis Menton theory. Thank you.